Hi, this is Marin Steiner, and this week I'm in Hawaii for the last week of General Chemistry 2, and this is Interactive Advanced Concept Presentation 8, where we're going to try and make kinetic sand. So we know that polymers are found everywhere on the planet and are used for many things like clothing, fiberglass, plastic bags, epoxy glue, Teflon-coated cookware, and even heart valves. There's both natural polymers and synthetic polymers. Natural polymers are also called biopolymers, include silk, rubber, cellulose, wool, amber, keratin, collagen, starch, DNA, and shellac. Examples of synthetic polymers include PVC, polyestyrene, synthetic rubber, silicone, polyethylene, neoprene, and nylon. Polymers are very large molecules made when many smaller molecules join together end to end. The smaller molecules are called monomers. In general, lots of monomer molecules make a polymer molecule, and the polymers formed are called addition polymers. So today we're going to attempt to make a polymer and set up a polymerization reaction. A polymer, also just recapping, a substance or material consisting of very large molecules or macromolecules composed of many repeating subunits. Due to their broad spectrum of properties, both synthetic and natural polymers play essential and ubiquitous roles in everyday life. So our ingredients for today's experiment are sand, which we have right here, straight from the beach, which my lovely assistants here have helped. Say hi. They're so excited.
Kaanapali.
Yes, Kaanapali Beach here in Hawaii. It's a little bit wet, so we'll see how that affects the outcome. We have two different bowls here, one here with some water, which we'll need for our experiment, and a bigger bowl right here to hopefully make this all work. So first we're going to pour some cornstarch into a bowl and add dish soap and mix everything together, and hopefully we'll get a pasty texture. I think I'm going to do it here. All right, so we've got our cornstarch, which is right here. Have some faith in me, guys. Have some faith. Apparently opening the cornstarch is going to be the most difficult part here. Alright, so here's our bowl. We're going to pour some cornstarch in. Let's start with that much right there and see what we get. And then we have our dish soap right here. So we're going to pour the dish soap until we get like a pasty texture. Let's see if we can go down. There we go. So we will mix this together here. I've seen a video of what's it supposed to look like, so we'll see if we can sort of make that happen. Let's try some more here. This is the story of how we run out of dish soap, correct? Yes, I agree. Let's see. It's not very wet.
Pasty sure is pretty. It is pretty. You can add
So let's add a little bit more. We're getting there here.
There we go.
Okay, so I think we're getting, just have cornstarch all over myself now. Every one of these seems to end up with things all over me. Okay, so I think we have a sort of pasty texture here. So now we're going to start adding our sand in pretty slowly, and we're going to move it around and see if we can get this to stick. Oh, there's extra things in our sand.
French.
Extra things. Okay, so we're going to mix this around slowly. I didn't add too much sand. I think what we're going to try and do is add some water. That maybe will help this along. Let's see if that helps. This is a gigantic mess is what we have created here. I don't think this is going to work. I think it's because the sand is... Actually, maybe this is working. But wait, there's more. So, I actually think this might be working. So, if we mix this and push it around, it definitely is working. That's kind of neat. There's some sort of shell in my sand, though.
I got you.
So, we definitely have created...
Oh. What is it? Kinetic sand.
We have created kinetic sand. That feels really strange. All right. Finally, after my last two experiments kind of failed, this one worked. So yeah, there we have it. So that's our attempt at kinetic sand. It's been a blast going through... move this camera up. It's been a blast going through General Chemistry 2 with all of you and General Chemistry 1 with some of you. And I'm sure I will see some of you guys soon in OChem, and we all will figure that out together. So bye for now, and happy holidays.
Aloha!